So we've got to find all second partials in this problem. That means we need f sub xx, f sub yy, f sub xy, and f sub yx. I'm going to start with my first partials. We need to find f sub x first. So f sub x means I'm going to take del x of e to the xy times sine of y. Now if you notice what's going on in here, the sine of y is just a function of y. So that's like a constant when I'm taking the derivative with respect to x. So I'm going to focus on the e to the xy by rewriting this. This is going to be sine of y times del x of e to the xy. Helps me keep my eyes focused if I do that. Now when I take the derivative of any exponential function, the derivative is the exponential function, and then times the derivative of the exponent. So let's write that out. We get sine of y e to the xy times del x of xy. And the derivative of xy with respect to x is just going to be y. So when I finish this all up, I have y e to the xy times sine of y. So this is my first derivative with respect to x. Now I'm going to go ahead and get my f sub xx. So this will be the second derivative that I'll find. F sub xx means that I'm going to take del x of the result that I just got, which is the y e to the xy sine of y. Now again, the y and the sine of y, those are just functions of y, so they act like constants. I can pull those out in front, y, sine of y, and focus on taking del x of e to the xy. All right, so again, we know the derivative of an exponential function is the exponential function times the derivative of the exponent. So this gives us y sine of y e to the xy times del x of xy, which is again y. And when it joins up in front with the other y, we end up with y squared e to the xy sine of y. And we can put a box around that one. This is our f sub xx. So we've done one of them. The next one will be f sub xy. So now what we're doing is taking del y of our f sub x. So I need to plug in f sub x, which I'm going to write it slightly differently as y sine of y e to the xy. Now what we have to notice here is that we actually have 2 or 3 functions of y, and they're in a product, and that's like a triple product rule. And I don't want to do a triple product rule because I tend to get lost in those. So instead, I'm going to treat y sine of y as one function and e to the xy as my second function. And I'll just do a regular old product rule, and then I'll see inside of that how the other product gets handled. Okay? So if I'm doing a product rule, I do the derivative of the first. So I get del y of y sine of y times the second function, which is the e to the xy, plus the first, which is the y sine of y, times the derivative del y of the second, e to the xy. Okay, so now I can really see how I'm going to handle that y sine of y, because in order for me to take del y of y sine of y, I have another product rule. Okay, so we're just going to go with it. It's fine. We have 2 functions. We have y is going to be the first one. Sine of y will be the second one. So this becomes the derivative of the first. I'm going to put this all in big brackets. The derivative of the first, that'll be del y of y times the second, which is the sine of y, plus the first is y times del y of the second, which is sine of y. Okay, so that just takes care of del y of y sine of y. I still have times e to the xy. Okay, plus y sine of y. Now del y of e to the xy will be e to the xy times del y of xy. All right, let's go through and take these last few derivatives that need to be taken. So starting from the left, del del y of y is 1. So that just leaves me with sine of y plus y times, well, del del y of sine of y is cosine of y. And then all of this is multiplied by an e to the xy. And then in the second term, when I take del del y of xy, I'll get an x. So adding this in here, I get plus xy sine of y e to the xy. I can leave my answer like that. I really don't need to rewrite it, although I do see that I have two terms that both have e to the xy in common, so I could technically factor it out, but there's really no need. I'm going to call it a day on that one and say this is my f sub xy. All right, now we're going to go to finding the first derivative with respect to y, which would be f sub y. This is equal to del y of e to the xy sine of y. So right away, we're not as lucky here as we were with f sub x, because now we have a product right away. We're going to have a product rule right away. So let's get a nice clean page here. All right, derivative of the first. I'm going to write this all out. Del y of e to the xy times the second, so times sine of y, plus the first, e to the xy, times del y of the second, the sine of y. Okay, we know now del y of e to the xy will be e to the xy times del y of xy, and then that sign is still there. Plus, now e to the xy times del y of sine of y, that's going to give me a cosine there. So I have e to the xy cosine of y. One last step here and I'll be done. Del y of xy is going to give me an x. So this gives me x e to the xy sine of y plus e to the xy cosine of y. And here I may go ahead and factor out an e to the xy so that I can do one product rule instead of two product rules. So one final rewrite on this is it's equal to e to the xy times x sine of y plus cosine of y. Okay, now I'm ready to go ahead and find f sub y. That means I'm taking del y of what I just found, the e to the xy times x sine of y plus cosine of y. And that means I have a product rule. So just to highlight again, here's my first function, e to the xy. My second function will be the x sine of y plus cosine of y. So I take del y of the first, the e to the xy, times the second, the x sine of y plus cosine of y, plus the first, e to the xy, times del y of the second, the x sine of y plus cosine of y. All right, now let's go ahead and take our derivatives. Del y of e to the xy, we should now know that it's going to give us x e to the y. So I get x e to the xy times the x sine of y plus cosine of y. And then in the second term, I have my plus e to the xy. And when I take the derivative with respect to y of x sine of y, I get x cosine of y. Taking the derivative of cosine of y, I get minus sine of y. And I could distribute some stuff and I could combine some like terms. I'm not particularly interested in doing that. So I'm going to go ahead and leave it as it is. And you can do the same thing as well. So like we did all the hard work, let's go ahead and walk away from that. Call it a day. Last one, f sub yx. Now this is going to require us to take del x of our original f sub y. So we're taking del x of e to the xy times x sine of y plus cosine of y. All right, again, we have a product rule. The first equation is e to the xy. The second one is the x sine of y plus cosine of y. So when I go ahead and deal with this, I'm taking del x of e to the xy times x sine of y plus cosine of y plus e to the xy times del x of x sine of y plus cosine of y. All right, now let's go ahead and take those derivatives. The derivative with respect to x of e to the xy, from up above, we know that's going to give us y e to the xy. And then we have this as times x sine of y plus cosine of y plus e to the xy. Now when we take del x of x sine of y, the derivative of x is just 1, so we are left with sine of y. When we take the derivative of cosine of y with respect to x, we get 0, right? And so we're pretty much done here. I could distribute if I like. I could also, I'll go ahead and distribute just so it looks a little bit better without that 0 there. So this will give me xy e to the xy sine of y plus y e to the xy cosine of y plus e to the xy sine of y. And this is my f sub y x. Now up above we talked about Clairaut's theorem and how the mixed partials should be equal. So if I look at these two long enough, the f sub xy up here and the f sub yx down here, I should be able to notice that they are indeed the exact same. Okay, and so Clairaut's theorem is definitely holding true, and we weren't even trying to show it. Okay. All right, let's try another one. In this one, we have f of xy is equal to y times the square root of x plus ln of y over x plus 2 raised to the xy. And again, I'm going to be finding all 4 of my second partial derivatives. So again, I have to start out with my first partial derivatives. I need f sub x. That means I will be finding del x of y square root of x plus ln of y over x plus 2 to the xy. And that third function tells me we need a recall. Okay, we need to recall how in the heck do we take the derivative of 2 to the xy, or 2 raised to any number. So if I'm finding d dx of 2 raised to an h of x, this is what we learned in Calc 1, it will give me 2 to the hx times ln of 2 times h prime of x. Okay, so we're going to translate that into the multivariate form when we get to that derivative. All right, so taking the derivative of y square root of x, the y will come out in front, and inside I'm going to take care of, we should think of this as x to the 1/2, so that we use the power rule. So it'll be 1/2 x to the minus 1/2 plus, and here the ln of y also acts like a multiplier. So I have ln of y times the derivative of 1 over x, which will give me a negative 1 over x squared. And then plus the derivative of 2 to the xy, that's according to up above, that's going to give me 2 to the xy times ln of 2 times del x of xy. Okay, so I'm going to go ahead and clean this up so that I have something nicer to work with. And I'm going to rewrite any exponents so that they're more conducive to taking derivatives of them. All right, so this becomes 1/2 x to the negative 1/2 times y minus, I can rewrite that 1 over x squared as x to the minus 2 times ln of y. And then now we're on our third term. The derivative with respect to x of xy is y. So right here, what I have is plus y, 2 to the xy times ln of 2. And that's my final answer for f sub x. But I'm not done, unfortunately. I have to go on to f sub xx. So f sub xx requires me to take del x of what we just found. 1/2 x to the negative 1/2 times y minus x to the minus 2 ln of y plus y 2 to the xy ln of 2. All right, so running a del x through and remembering to treat all the y functions as constants or just coefficients so that 1/2 y can come out in front. You get 1/2 y, and I take the derivative of x to the minus 1/2, I get minus 1/2 x to the minus 3/2. And then I get to the ln of y, and I take the derivative of the x to the minus 2, or really negative x to the minus 2, and I get plus 2x to the minus 3 times ln of y, plus, and now this last one here, I've got the y and the ln of 2 are constants, and then I'll multiply by the derivative of 2 to the xy, which is 2 to the xy ln of 2 times the derivative, del x, of xy. Okay, cleaning this up a bit, and I'm going to clean it up fully here. So the first term gives me a negative y on top. In the bottom, I have a 2, and then an x to the 3/2 downstairs is what it would look like, and that can be written as x square root of x, plus 2 ln of y over x cubed, plus, okay, now when I take that derivative of xy with respect to x, I get another y. So I have y squared, and then I also have ln of 2 squared, and then times 2 to the xy. And this is f sub xx. That's as good as it gets. All right, so sometimes we're going to find derivatives and they are not going to be pretty and it'll feel painful to go through them. Just know that it's okay if they're ugly. You know, your final answer is your final answer. And there is nothing we can do to simplify this either. All right, one more. After the f sub x, we need f sub xy. So we're going to be finding del y of our original f sub x, which was 1/2 x to the minus 1/2 y, and then minus x to the minus 2 ln of y, plus, and then we're going to have a y, and I'm going to write this as y ln of 2, and then times 2 to the xy. All right, and then from there, as I run this del y going through, the x functions are just going to be coefficients for my y functions, and so I have to treat them as such. And I may, go ahead and rewrite them as well. That 1/2 x to the minus 1/2 could be rewritten as 1 over 2 square root of x. And then the derivative of y with respect to y is just 1. And then we have minus, well, this x to the minus 2 can be written as 1 over x squared. And then times the derivative of ln of y is 1 over y. And then plus, I have my y ln of 2 times the derivative of 2 to the xy. We're going to go with what we have up at the top again. So we'll get times 2 to the xy times ln of 2 times del y of xy. All right, this will clean up quite a bit. When I rewrite this, I get 1 over 2 square root of x minus 1 over x squared y plus, and then this looks like the del y of xy gives me an x, so I get plus xy ln of 2, I have 2 of those, so I'll square it, times 2 to the xy. And this is my f sub xy. Okay, so now we have f sub xx, we have f sub xy. Now we have to get f sub yy, which means we have to start off with finding f sub y. Okay, f sub y is going to be del y of our original function, so I got to find that, y square root of x plus ln of y over x plus 2 to the yx. All right, so I'm going to run a del y through, and again, I'm going to treat any of the x functions that are with a y as coefficients, and so they're not going to affect my derivative other than to be multipliers. So the del y of y square root of x, I'm going to go ahead and write it as square root of x times the derivative of y with respect to y is just 1, plus the 1 over x times the derivative of ln of y with respect to y is 1 over y, plus the derivative of 2 to the yx, we've done this a few times now, this will be 2 to the yx ln of 2 times del y of xy. All right, we can clean this up a bit. This is going to equal the square root of x plus 1 over xy. And then, you know what, actually before, instead of writing it that way, because I know I have to take another derivative, so I should be very careful about this, I'm going to write this as xy to the minus 1 so that I can deal with it as a power rule. And then the last part, the del y of xy is going to give us an x, so we'll have plus x ln of 2 times 2 to the yx. All right, now let's go ahead and find f sub yy. Again, we're going to take del y, but we're taking it of f sub y. So the square root of x plus xy to the minus 1 plus x ln of 2 times 2 to the xy. All right, the derivative with respect to y of the square root of x is 0, which is really nice. The derivative of xy to the minus 1, that'll give us a minus times, in quantity, the xy raised to the minus 2 times del y of xy. So that's our chain rule coming in. Plus del y of x ln of 2, 2 to the xy, we're going to get an x ln of 2, and then we're going to get the derivative of 2 to the xy is 2 to the xy times ln of 2 times del y of xy. So we've got to deal with that del y of xy twice in this problem. All right, when I simplify this, it becomes, let's see, so the del y of xy is just going to give me an x. Okay, so this factor right here just gives me x. So when I rewrite that whole fraction, what I end up with is an x in the numerator, or in minus x in the numerator, all over an x squared y squared. And that actually simplifies, so we may take one more step there. And then we have plus, and it looks like we have that del y of xy again, and that gives us another x, so I get plus x squared times ln of 2 all squared times 2 to the xy. And we have one more step to simplify because of the x's in the fraction. This will finally be a negative 1 over xy squared plus x squared ln of 2 all squared times 2 to the xy. And that is our final answer here. This is f sub yy. Okay, one more here. We need to get f sub yx. So I'm taking del x of my original f sub y, and I'm going to rewrite my f sub y just ever so slightly to set it up for taking a derivative with respect to x. So instead of writing square root of x, I will write it as x to the 1/2. I'm still going to write the xy pair raised to the minus 1. and then plus, here I'm going to pull the ln of 2 out and get my eyes focused on x times 2 to the xy so that I see that I have a product rule. Okay. All right, let's go and run this del x through. For the first term, I get 1/2 x to the negative 1/2. For the xy to the -1, I have a chain rule, so I'm going to use the power rule first, minus, in parentheses, xy, raised to the -2 times del x of xy, plus ln of 2, and now here's my product rule. So I have the derivative of the first, del x of x times 2 to the xy, plus the first times del x of the second, which is the 2 to the xy. All right, now I have a few more derivatives to take. Remember, del x of xy is going to give us a y. So when I rewrite this, the first term becomes 1 over 2 square root of x. And then I get, from the del x of xy, I get a y in the numerator. So I get minus y over x squared, y squared. So that'll be something to simplify when I come back. Plus ln of 2, and then inside here I'm going to take my derivatives. Del x of x is 1, so I just have 2 to the xy, plus x times del x of 2 to the xy is 2 to the xy times ln of 2 times del x of xy, which is going to give me a y. Okay, I've got to clean this up quite a bit here. All right, this gives me 1 over 2 square root of x minus 1 over x squared y plus 2 to the xy ln of 2 plus xy ln of 2 all squared times 2 to the xy. So that's what I get on my distribution. And that's about as good as I can make that one. And let's put a box around it and then compare it to f sub xy. When I compare it to f sub xy up above, it looks like, well, it looks like I'm missing something in my ln of my f sub xy. So let's go back up and look and see what I could have done there. So my f sub xy, I have my 1 over 2 square root of x, that's good. I have my minus 1 over x squared y, that's good. I have my xy ln of 2 all squared times 2 to the xy, that's good. It looks like, where did I miss something? It says taking ln of y. Okay, I see it. I see it already. All right, let me go back here. It's a great learning experience. We all make mistakes. All right, so it was here that I made a mistake, because when I took del y of y ln of 2 to the xy, I should have had a product rule. And so what this highlights is how easy it is to get lost in your variables. I was probably thinking x's. Even though I wrote del y, I was still thinking x's, and so I only saw one function. So let's just get a little a fix on that. Del y of y ln of 2 to the xy. I have a product rule, so I can pull the ln of 2 out and focus on the del y of y 2 to the xy. Okay, this is equal to ln of 2 times, all right, derivative of the first, del y of y, times 2 to the xy, that's our missing term actually, plus the y times del y of 2 to the xy. All right, taking the derivatives, this is equal to ln of 2 times del y of y is just 1, so this is 2 to the xy, plus del y times del y of 2 to the xy gives me y 2 to the xy ln of 2, and the derivative of xy with respect to y gives me an x. And when I rewrite this and distribute everything, it gives me 2 to the xy ln of 2 plus xy times ln of 2 all squared times 2 to the xy. All right, so this piece right here should replace this piece right here. Okay, so if I do that, you know, if you watch notes, if you just read through notes on this, you won't know what happens, but I'm going to go ahead and fix this now by replacing that. Okay, so going in here and erasing only what I need to and getting back the color that I need. This is going to be plus the 2 to the xy ln of 2 plus xy times ln of 2 all squared 2 to the xy. That is the final answer on that one. And up here, what I needed to rewrite, this y ln of 2 times 2 to the xy ln of 2 times del del y of xy, that was totally wrong. So I'm going to rewrite that as well. So what that should have been was plus ln of 2 times del del y of y times 2 to the xy. And then I will put an arrow over there to show that side work to get what we want. Okay, so now, sorry about that. To go back to comparing f sub xy, which we just found formally incorrectly, what does it look like f sub yx? And it looks identical. So we're good there. That's awesome. Okay, so as you can see, it is extremely tedious taking these second partial derivatives because we have to calculate so much. I mean, we calculated 6 derivatives to get 4 answers. And when the function is difficult, it's easy to make mistakes. Super, super easy to make mistakes. So, moral of the story is be very, very careful